by YouTube a number of months ago, but I have kind of this other one that might be more useful in space flight itself. I offered one for like atmospheric re-entry, and here's kind of is a crude drawing, but it kind of gets the idea. This here is the main, I'm tempted to call it fuselage of the mothership, and this here is its main propellant nozzle. And this little thing, I know it looks like a queen termite, but it's actually supposed to represent an interplanetary spaceship. But anyway, I'm sure you're all chawing at the bit trying to find out what this little thing is, and that is the projectile. It's a tethered projectile, which basically runs on rocket. It basically borrows fuel from the borrows propellant from the main tank, and it essentially shoots ahead of the spacecraft and effectively improves deltaV for the gives it more deltaV than the conventional system would normally allow, than the specific impulse would normally allow. Even though there are propellants that can provide a higher deltaV, that can provide a higher specific impulse than liquid hydrogen and liquid oxygen, they have some problems that genuine oxidizer type propellants seem to be immune to. For one thing, a lot of these propellants that have been proposed are ones that tend to have somewhat less than perfect reactions, in which basically only a portion of them actually becomes exothermic, actually produces energy, and that's one of the things that specific impulse is a function of, is essentially energy over mass. It's high energy, low mass is the best way to get high specific impulse. And if a propellant is like 10 times more, if you have a propellant that's 10 times more efficient than say liquid hydrogen, liquid oxygen, but less than 1/10 of it actually participates in the reaction, you actually lose more than you gain. Whereas hydrogen and oxygen seems to be one of the best ways to both get a high efficiency and a good stoichiometric combustion. Basically it's a lot easier to get hydrogen and oxygen to react evenly, without any real waste. And I might add that there are a few propellants that actually have higher specific impulses than hydrogen and oxygen, but both of them, at least the two that I've heard of, are a lot more toxic. Like one of the most powerful of all rocket propellants is hydrogen fluorine, which is typically toxic. So assuming existing propellants, hydrogen and oxygen appear to be the best one in terms of efficiency, getting more buck for your bang, if you would. So we'll assume that if you can't really get a better specific impulse, this may be a good way to get more out of a given specific impulse. Because what basically happens here, want a pointer here, give you a little pointer. This oxygen, it causes it to take off here, and as it takes off, it's running. It's actually putting a G-force on the spacecraft. It's subject to a G-force, and that's going to translate into basically getting more thrust than the amount of thrust is. Which if that can be repeated for it sort of depends on how many cycles it can go before it has to refuel or refill, and then it could use probably most or all of its propellant. It could use this for deltaV while established in space flight, and I know this could be useful where a lot of thrust is required, though it wouldn't be quite as efficient. But anyway, I think that kind of gets the idea. And that has nothing to do with like this. That actually has something to do with another YouTube I made. But anyway, there's the spacecraft, and like there's a projectile, and it goes. It gets its tension, and it starts getting reeled back in as it continues producing thrust, which helps add to the force that's acting on it. And I don't see why there would not be at least some savings in propellant. And Superman would save your Herbie.